Hi, good morning in India. I see about 5, 6 people. So we'll wait a couple of minutes for others to join. So I see, yeah, SSMS keep joining.
Good evening, sir.
Good evening. And good morning to you.
Good morning. Yes, sir.
Do we have everybody from JSPM?
No, sir.
Hey, Vasant, I think, we should start on time. There's no
Okay.
point in waiting for everyone to get in.
Okay. I think, yeah. Are you good? Yeah, SSMS, are you guys all set up?
Yes, sir.
Okay. All right. Can everybody see my slides?
Yes, sir.
Okay. AISMS, can you see my slides?
Yes, sir.
Okay. All right, I'll go ahead and get started. First of all, good morning and welcome to everybody. Today we are going to cover. Let me adjust some settings. All right. All right, so we'll go ahead and get started. Today's session, we're going to cover introduction to machine learning and some of the use cases for machine learning, and then try to see some of the existing tools and platforms that are out there. So you might have heard the terms artificial intelligence and machine learning, and they sound similar and somewhat confusing. So let's get our basics straight. So artificial intelligence, as you can see from the image, is a wider field. generally anything that enables computers to mimic human intelligence or logic is called artificial intelligence. It's been around for a long time. It was mainly used in movies. And then a subset of that is machine learning, which is actually using just statistical techniques that enable machines to improve solving a problem in a particular domain or particular category of problems. And then deep learning is actually even a subset of that, a super specialization of that says uh, it's composed of algorithms that train based on given data uh, and can be used for speech or image recognition. And it's called deep learning because it tries to mimic the neurals in our brain. So they don't biologically mimic the brain, but conceptually they try to use a multi-layered network to solve that. So there's some history on that. So basically, the artificial intelligence was coined in 1956, and then it stayed that way till almost 2015 or around that, when Google started using machine learning and specifically deep learning to solve problems. And that was the first, or one of the first uses of uh, uh, machine learning or deep learning solving speech recognition. So that's just some history. Uh, so we are going to be learning machine learning because artificial intelligence is too wide, and so far nobody has been able to build a human equivalent intelligence. So we're going to focus on deep learning, uh, which is basically it's a multi-layer network where each layer, so it tries to mimic not how like a child would learn, but how uh, if you have multiple layers, then each layer is solving for one or more features. And then once you go through multiple layers, it gains understanding on that subject. So that's just some theory. We'll go into detail in that. You might have also heard IoT or Internet of Things, and they are not the same, but Internet of Things involves basically collecting sensor input like sight, sound, touch. So a lot of the phones can measure steps. So that's like a sensor. And then that generates a lot of data. And then machine learning or deep learning is used to make sense out of that data. So that's how the IoT and machine learning are connected. Uh, so before I continue, and you can just respond on the OB incubators group. How many of you have never heard of machine learning? So you can just respond if you have never heard of machine learning.
We don't know what machine learning. Never heard.
And you can respond on the OB incubators WhatsApp chat. So sounds like most people have at least heard about machine learning. So let's just a very high level uh, take a look at the broad categories of machine learning. So as you can see, there are three types. So supervised learning means uh, it needs input data, and instead of normal programs where you have to provide all the rules to the computer and then it just follows the rules, which is if then else or loops or whatever, and it just follows what you coded. It won't be able to do anything more or less than what you have coded. Whereas machine learning takes a different approach. It So for supervised learning, it will take the input data that you give, and it will go through a phase called training, and will create a model. A model is roughly the computer's version of rules. And again, this is not this is approximation, so it uses a lot of statistical methods, probability, and things like that. And that's how it comes up with what can be loosely called as a set of rules. So there are machine learning doesn't actually create any piece of code that specifies all the rules, but it creates a mechanism that acts like a set of rules. So supervised means you give the data, and the data contains uh, all the information. So you tell if this is the data, this is the output that it should give, and then the supervised learning model learns from it and creates something called model. And then when you give it new data, then it can predict the outcome or uh, solve the problem. So that's supervised learning, meaning you as a data scientist or as a person has to provide the data and the meaning of it. Unsupervised means the machine actually watches lots of data and tries to find patterns in them, and uh, it just basically produces groups of the input data that it received. And then reinforcement learning is where the machine learns by itself by uh, by looking at the outputs, and then the rewards are fed into as input, and then the machine learning knows which way is a better way. So you might have heard recently Google uh, did a man versus machine competition with a Chinese game called Go, which is super complicated. And so Google had basically two machines play against each other, and that's how they learned, and they were able to beat a person. So that's reinforcement learning. Uh, so moving on. Uh, so there are different types of machine learning. So it's at a broad level, it's just called machine learning, and then it either goes into supervised or unsupervised. So under supervised, it could be classification, which is image classification, identity fraud, uh, customer retention, or it will go into more of a statistical one, which is market forecasting, weather forecasting, uh, advertising popularity prediction, like that. And then reinforcement learning is like a game AI or a robot navigation. And then unsupervised learning example is customer segmentation or recommendation system that you might have seen on Flipkart or Amazon, where based on your shopping history and shopping histories of other people matching your profile, you are suggested other products. And so that's unsupervised. So you're not explicitly telling Amazon or Flipkart what you like and what you don't like. It just watches the data and figures it out. So that's a good example of unsupervised learning. Uh, so machine learning, there are lots of algorithms. If you have done any kind of statistics, you might have at least read about some of the algorithms, decision trees or linear regression. So for now, just remember that there are multiple algorithms. So there is no one single thing called machine learning or deep learning. There is multiple algorithms that are used depending upon what problem you are trying to solve. So that was some of the history or theory behind machine learning. Now we'll move to slightly some practical approaches. So usually the question is asked, can machine learning solve everything? And the answer is, at this time, no. It is most beneficial to solve certain types of problems. So what can it solve? Uh, if it's a finite set of rules, then machine learning is more likely to solve it. So the rules don't have to be all pre-known, but uh, if there are, so for example, like face detection. So it's a human face detection, so all human faces have some lot of things in common, and the number of variations is not infinite or unpredictable. Same thing for email spam filtering. So those would be good cases of use cases for machine learning, where uh, it can, if you can provide enough data, it can learn, uh, you know, or it can solve problems like face detection or email spam. Uh, Now, quality of data matters. So in machine learning, especially the supervised part, you have to provide the data. So unless you can tell the computer what kind of data you are giving and what does it mean, it cannot learn from it. Or if you give it incorrect information, it's going to not be correct. So one example of that would be like handwritten recognition. So you can write like 1 through 9 digits in multiple ways, but if you don't label it correctly or don't give good examples, then it will not be able to learn that. But if you give it enough good examples and label them correctly, it can solve that problem. So one example you might have heard is self-driving cars. That data collection is hard because there are nearly infinite situations or use cases, and so a company like Google, they're working for like 6+ years, but they have still not completely solved it. They made a lot of progress, but not solved it. So quality of data matters. Tolerance for error, meaning because it's probability based, the error that can be tolerated in solving that problem decides if machine learning is suitable or not. So if it's a spam detection, even if the accuracy is say 98%, it means 2% of the time the machine learning model is going to incorrectly label something as spam or skip something that should be spam. But because it's just a spam email, it's not going to cause a lot of problems. But somehow if machine learning was used in heart surgery, that would, the margin of error is pretty much close to zero. So you do not want to use machine learning if its accuracy is not almost 100%. So those are some of the examples. So uh, let us actually take a look at an example. So it will probably help. It'll help how the problem is solved. So let me share. Uh, Let me share a Google solution. So let's see. Mm. Share. Okay, let me switch to another one. So this is, if you go to js.tensorflow.org, you will see that they have a lot of examples. And I'm going to try here, but I think it uses camera. So I may have to disable the camera on this meeting, and because I'm going to use the camera. So if you don't see the example, please please respond on the WhatsApp. Otherwise, I'll assume that you guys can see it. So yeah, I had to turn my camera off. So let's see if that is going to work. All right, I'm stopping my video. Let's see if this will work now. All right. So can you see my screen?
Yes, sir.
Okay, can you guys see my screen?
Yes, sir.
Okay, thanks. So this is a Google example. So this is what I'm talking about, training data. So right now, there are 3 ways it can categorize. And I'm going to try to train it just simple left, right, and up. And then it's going to say those words, right? So left, right, and up. So the way it is called, so we'll go through some terms here. I'll move myself out of the picture and so I'm going to train some data. So right now it has no data, as you can see here, 0 examples. So I'm going to train and basically say that whenever I take this action, it is going to uh, uh, basically this is the green category, and then it's linked to, and it's going to say the words left. So I'm going to say left. So this is that, and then I'm going to train it. So now it's going to analyze these pictures, and that's the data I'm giving. And the label I'm saying is whenever you see anything like this, it's left. So you can probably see that. So right now I only have one thing left. So whatever I do, it's going to call left. So that's not good. So let's train it some other way. So we'll say up. So we'll call that up, which is the last one. So I'm going to call this as up. Whenever I do something like this, it's up. So as you can see, if I give it less data, it's not going to work. So I'm giving it a lot of data. And then now it can detect that. So now left, up. So it can correctly now differentiate data, but I only trained on 2 categories. So if I do anything else, it's going to get confused. So like I'm just randomly doing something, and it's not going to, like I haven't trained it, so it can't tell me the answer. It's only 2 things it can do. So now let's train it properly. So, or we can go like this. That's right. So all right. So you can see here we trained. So let me just walk through what we did. So this is our training data. So I just gave it 75 examples and said whenever you see something, some picture like that, then you call it left. When you see a picture like this, call it right. And then when you picture with up, finger pointing up, you call it up. And then once I trained it, then now I can now, let's see if it works. So this is up, so it's working correctly. This is left. Right. And then let's try to confuse it, right? So I'm going to say, so because this is how I trained it. If you give it wrong data, if I use some other fingers, like I use 4 fingers, if they're close, it'll probably work. But like if I did like 2 fingers like that, it looks like up. But if I do like this or like this, it's probably going to get confused. So that's the data quality comes into the picture. If I don't give proper data, it's going to get confused. So this is the correct data. So it's up, and then right. So I trained it with an index finger, but it's smart enough to say that this is a distinct pattern, so it can say that I'm pointing right, and so it can correctly say right. So I gave it training data. I labeled it by saying left, right, or up, and then it went through training by I clicked on the train button, and so it trained it. So now it actually learns any picture or any image that looks like somebody's pointing to the right. It doesn't have to be the index finger. It could be like more fingers, and it will still say right. And then same thing for left. So it still says left. So that's an example of how machine learning can. So I really did not set any rules. I just gave the pictures, and then I just said that these type of pictures correspond to this category, and then it learned from it, and it can handle some amount of variation. All right, so I will stop this for now and go back to our presentation. All right. So, and let me start the camera back up. So was this useful to know what machine learning is used for and how it works at a very high level?
Yes, sir.
All right. Let's see. Do we have AI SSMS? Can you guys hear? Good. So we talked about these three things, and we saw an example on Google. You can go to that site, js.tensorflow.org, and there are some examples you can try out. So what problems can machine learning not solve or is not good at? So some examples are, predicting profits from the introduction of a completely new and revolutionary product line. So machine learning can't just solve any kind of problems. If there is no pattern or there is no input data, and it has never seen that kind of data, most likely it won't be able to make sense out of it. So extrapolating next year's sales from past data, that machine learning can do. But when you add the variable of when a new competitor has entered the market, and that is going to affect it, machine learning, unless you give it some data around that, it's not going to learn anything on it. So those are the problems that machine learning is not good at. And then anything that requires 100% results, absolutely no room for error, such as legal regulation or heart surgery or financial transactions where you have to transfer uh, or you have to give specific amount of money withdrawing from your account. That time you can be wrong by even one paisa. So those are some of the things where machine learning in its current form is not really suitable. So we just saw some examples of where machine learning can be used. We saw an actual demo of how it works at a basic level, simplistic level, and then some of the unsuitable problems. So some of the tools and platforms. So IBM has its Watson, you might have heard about it. Amazon has its own machine learning. Alexa is example. Google has one. So there's a lot of companies doing that. So some of the frameworks that you might have heard or you may hear if you read up on this topic. So there is Cafe from Facebook, Torch and PyTorch, and then TensorFlow from Google. And so there are a lot of frameworks, so there are a lot of options. So we are going to be using the Google's version, TensorFlow version, so I showed you that example. But there are other options. So the difference is there are some libraries that have been created that will help you develop machine learning programs. So TensorFlow is from Google, and that is what Google uses for speech recognition. So all on your Android phones, if you have one, the Google Assistant or speech translation, that that functionality is developed using TensorFlow. So that's one of the leading libraries that is out there, which can be used to develop machine learning programs. There is obviously Apache, which is open source. They have some machine learning stuff. Microsoft has it. Uh, Scikit-learn, you might have heard it in Python side. Those libraries are available, and there is lots of them. NVIDIA, which is the graphics card maker, they have their own library. So again, there are a lot of options, and you may hear different terms, but they all conceptually mean the same thing. So we looked at some of the examples on that. So I'm not going to try, but we can just talk about some of the other examples available on that. So let me share that part. So this is Google has created a version of TensorFlow, which is their library, in JavaScript, so it runs in browser, and they have shown some examples. So you can do emoji scavenger hunt, where you use your phone's camera to detect these kind of emojis, and then accordingly it moves. Or you can do scavenger hunt. Using webcam, you can play Pac-Man, where you train it just like we did, left, right, up, down, and it can move the Pac-Man around. And this is the example we saw. It's called teachable machine. So you can do anything as your input, and then train it, and then it'll do the three categories. So there is a real-time performance by neural network, so you can try that out. Real-time pose estimation. So I think this one is somewhat interesting. Even that I had to stop the camera, so I will not go there. All right, so those are some of the examples. Another one we have is so basically when a baseball is thrown or cricket ball is thrown, you can predict the pitch and the pattern and do that. So there is a bunch of examples you can try. Another cool example that you can see. Let me see if you can see that. Yeah. Okay. So Google created this site. You can go by going to autodraw.com, and then what they have done is they have taken commonly drawn symbols, and then based on what you draw. So I'm going to draw a very simple house, and you watch there. As I drew a little bit, it started guessing what I have drawn, and so before even I drew proper things, it was able to guess that I'm trying to buy a house, and it showed me a bunch of options around that. So I can just choose one that closely mirrors that. And it is, so this is Google's sort of way of showing how machine learning can be used for even simple tasks. One of the examples, if I just draw a simple circle, it tries to guess what I'm actually trying to draw, which is it could be a lemon or a circle. But if I do the sun rays, then watch as it changes. So till I drew almost all around, it did not know that I'm drawing a sun. But as I did that, it gave me more options on that. So I was trying to basically draw this one. Another example is, so if I want to draw a cycle, I am intentionally drawing it sort of incorrectly. So, and then I'm going to, so now, so if I intentionally draw it wrong, it is not going to guess it because it's trying to learn from this example. So if I do a scooter, that it will probably recognize better. So let's see, I think it drew a tractor. So I guess my drawing is not that good. So maybe. Okay, there it is. So now it could tell that I'm drawing a scooter and different variations of that. So all these things in the background are using machine learning. And so I'm purposefully giving you more examples so that you can at least start thinking and make sense out of that. Another example of the learning process that I want to cover is, so let's look at different problems. So if we are trying to come up with a model that decides how to differentiate between the blue dots and the orange dots. So there are a few layers. I'll increase more layers here. And then I'm going to run the program. And so it very quickly narrows down on what the solution is. But if I decide to learn slowly for more accuracy, it'll take, you will see how it tries to learn and tries to solve it. So I think this is very slow. So probably go a little bit faster. So now by repeatedly trying the curve, it was able to solve the problem fairly quickly. So those are some of the examples of machine learning and how the different layers matter. So we can try, if I take out the layer and try to run again. So it takes a bit longer for it to correctly figure out how to solve the problem. Currently, it's not able to solve it properly. So it's going on for quite some time. And now it solved it. So basically the layers matter, and the right combination of it, layers decide how quickly you can solve the problem and how accurate it is. So you can overshoot and then it will probably never be able to solve. So as you can see, it's because I intentionally took the wrong data set, it is not able to solve the problem. It's going in one direction and then another direction in terms of solving the problem, and it never is able to solve the problem. So machine learning is not exact science. It takes a lot of repetition, and it takes the right data to be given and the right amount of increments on how you can learn. So that's what is needed for machine learning. Right. So switching back to to the slides. So if you search, there are a lot of Python-based machine learning tutorials and programs. So yeah, so I think for this session, we covered a lot of material. So I want to pause a bit and open it up for any questions that you may have on the material we covered. So please unmute your microphone if you want to ask any questions, or you can ask on the WhatsApp group also. Any questions?
They can't hear us. Yes, you can hear them. That is more. That is more. Excuse me, sir. So can you hear me?
Yeah, I can.
What are the layers you were talking about?
So in deep learning, just like in brain, you know that brain is made up of neurons, and it's many layers of neurons. So when the signal is sent from the eye to the brain, it goes through the multiple layers. So in machine learning, they tried to build uh, something like that, where so the example is what I was just showing earlier. So when I say layers, it means that you can see that it is going to, by intentionally solving or focusing on one part of the problem, it solves that part, and then next one and next one. So for face, probably a good example is face recognition, human face recognition. So the computer, for it to recognize a face, first it needs to know uh, if it can zoom in on some of the key features. So if the face contains two eyes, one nose, and a mouth, then obviously the picture is where a person is looking straight in the camera. And then the next layer of that is depending upon the different locations of uh, eye and nose style, then it can differentiate between different faces. So that kind of problem is solved by layer. So each layer can focus on some of the features, not the entire thing, and solve the problem.
Okay, sir.
Does that make sense?
Yes, sir.
Okay.
I have one question.
Sure.
I'm audible.
Yeah, go ahead.
See, suppose if I'm using a database, like typically I have used the PIMA diabetic data set, and the data set is unbalanced. Like I'm having more of the non-diabetic cases and less of the diabetic cases. So in that case, do I have to normalize? Like I have to just take equal number of diabetic and non-diabetic data set cases.
Yeah, so typically in a database, so are you talking about diabetes?
Yeah.
Okay. So a person is called diabetes based on multiple symptoms. Some are highly important, so obviously your sugar level, but when you are trying to detect diabetes early, that number is not beyond a threshold. So you have to look at multiple factors. So what machine learning will do, so as an example, uh, for diabetes, uh, normal rules would require you simple if then else conditions. So the simple condition would be if blood sugar is above certain limit, then most likely you are diabetic. So that would be rule based programming. Whereas machine learning would actually look at many samples. So they would look at different uh, uh, sort of different readings in blood samples of many people, and then if the data has been labeled that certain blood samples are of diabetic people, then it will actually learn from the different characteristics. So it may be glucose level, it may be some other elements in the blood, and then it will try to create a model that uh, there is no straightforward if then else rules, but it takes into account multiple factors, and then based on the pattern that it has seen in the training data, it can then correctly diagnose a diabetic person or not, even though their specific blood sugar may not be high.
My question is like number of cases, like whatever the cases I'm having, tuples I'm having.
Okay.
So more of the non-diabetic tuples I'm having, and I'm having very less cases of diabetic. My data set is unbalanced.
Yeah. Okay, I see what you're saying. So if the data set is imbalanced, then the accuracy for the data set that is bigger, it can be probably more accurate on that side. So usually for a good training data, it needs to be sort of equal spaced or equal weighted so that you can solve uh, basically all kinds of problems. But if you are trying to solve a problem that is simple categories, then the balancing uh, may not matter if some categories are very clear, there's not much variation. So if something is category X, and if these things are true or false, then it's always category X. Then you could have less data samples and it will still work correctly. So I guess somebody is writing that. So one example I can give probably is, so like auto draw, right? So auto draw is basically I'm giving it, Google already has a model developed based on commonly drawn symbols. So it has like tons of them. So now it has been trained, it has a model, but it's a limited model. Like if I just drew something simple like this, it tries to randomly match. And so it's not going to be accurate. So this is a good example of the training data set doesn't have anything that matches this. So it randomly picks up on somewhat close. So this is some kind of curve. So it just showed me things that are curved. I didn't draw any of that, right? Or if I do something like this, then what I've drawn, because I was not clear and its training data did not include the right data, it was not able to correctly predict. I mean, look at the variation. It could be house, it could be goggles, it could be animals, it could be uh, fish, it could be anything. So does that help?
Yes, sir. Is there any doubt here?
Okay, any other question? Anybody else have any questions?
Sir, suppose we are using a neural network, some hidden layer already, but we are fixing the threshold frequency.
No, you don't have to. You don't have to set the
Because
frequency.
we are getting some data.
Yeah.
We have set some conditions.
Yeah, so we'll get to that, but I can answer right now. So machine learning has a concept called features. So whatever your data, you identify what are the important characteristics that matter. And then in your training data, you say, I have 10 features. So if I want to identify, let's say a face, then I'm going to say the features are, position of eyes, position of nose, uh, size of lips, forehead, size of forehead, and things like that. And then when you have thousands of samples, you're going to say that when You don't have to explicitly say that the distance between two eyes is this much and the nose shape is triangle or whatever. You don't have to say that. So you just say these are all my features, and then you just give lots of examples, and the machine learning model figures out based on the data uh, the relationship between those features that you identified and output that it saw in the data, and it figures out the rules by itself. So it almost sounds like black magic, and there is there is nothing that you can look at to say if it is doing it right or wrong. The only way you can check it is give it test it, give it some test examples and see if it can correctly predict what you're looking for. All right. Does that help? Okay. Any other questions?
We are basically using Veka. Veka is a data mining tool that is by Veka University.
Sorry, can you repeat that?
We are using a tool called as Veka. WEKA.
Okay.
Which is the product of Veka University. And Veka is also having all these facilities, and basically it is written in Java only. So
Okay.
So, industry, are we using that Veka tool or?
Yeah, I mean, so the standard libraries that are currently rated highly. So TensorFlow is by Google. Cafe is by Facebook. And so obviously these are big companies and they are using it. So their libraries or their tools obviously have been tested internally, and all of them are open source. So people have also tried it and the accuracy is high. But there are lots of companies creating lots of models. So I shared some of the examples. So I personally have not seen the one that you mentioned. But basically, you can see there are a lot of libraries. So each one has its own strengths. So we'll have to look at sort of what you have. So if there is some information about it, if you put it in the WhatsApp group under OB incubators, then I can take a look at it. Okay, sure. All right, so we are almost at the end of the hour. We covered a lot of material, so I don't want to overload you. So between now and tomorrow's session, if you can read up, and basically if you look at some of these examples, so if you go to tensorflow.org or js.tensorflow.org, there are a lot of good examples that you can try without knowing anything about machine learning. And you can see how by giving different input data, you can either improve accuracy or accuracy goes down. So that's what you can do between today's session and tomorrow. And then tomorrow we'll talk about some actual examples, and I will walk you through a use case on how we can use machine learning to solve a real problem. So that's coming up in tomorrow's session. So I think that's all I have to cover at this time. Anybody has any other last minute questions? Okay, so if not, then we'll end here. Uh, and then we'll meet again tomorrow. Tomorrow is when we'll have some actual examples or use cases that we'll walk through. So thanks everybody. I think we are moving at a pretty good pace. Let me know if this is too fast. All right, thanks. And bye. Let me end this.
JS famous होता है?